Hello everyone, this is the problem from electric field chapter 22 from Resnick Halliday and Walker, and the problem number is 12, which is 10th edition of Resnick Halliday and Walker. So in this problem we say that there are two charged particles, basically the electron and the proton, in uneven arrangement in a circular track of radius r. This r is the 2 centimeter. So they say that the uneven arrangement of these charged particles, so this is actually the electron, this is actually the proton, this is again proton, this is electron, and this is actually that again proton. So I label that particle as a number. Say this is actually that particle 1. Say this is actually that particle 2, because they have the same charge, only the polarity is different, so it will be easier for me. So this is actually that particle 4, and this is actually that particle 5. They are in uneven arrangement because the angle between particle 1 and 2, theta 1, which is the 30 degree, the angle between the particle 2 and 3 is angle is theta 2, which is 50 degree, and angle between particle 4 and 5 is 30 degree, and the particle 5 create an angle with the x-axis is 20 degree. Now they asked me to find out that net electric field that going to produce at that center over here. Fine, I'm going to draw that electric field first. So vectorically I'll draw that free body diagram. Say since this is a negative charged electron, so electric field at the center would be towards that direction, right? So I label by that. Basically this is the electric field for particle 1, so this is the E1. Particle 2 is a positive, which is proton, then the electric field for this one would be towards that direction. I label that. This would be that E2. Particle 3 is again, that is the proton, it's a positive. The electric field for that one would be towards that direction. Although my drawing is not exact, you can consider. So this is would be that E3, and E4 is the particle is again is negative. Now the electric field for this one would be towards itself. Then I can say this is would be that E4, and E5 is again positive. Then I can say that the electric field for this one would be towards that direction. So this is actually that, sorry, it would be that E5, right? So these are actually that electric field at the center of this circular track. Now I have to find out resultant of this electric field or resultant of this vector. Fine. Say I know that magnitude of this particle is same, right? Which is actually that you can say that the charge of the proton or charge of the electron is basically equal 1, which is actually 1.6 into 10 to the minus 19 coulomb. They give me the radius of the circular track, actually that 2 centimeter. Fine. Now I can say the electric field in general of this charged particle at the center will use, that should be that kq over r square, right? This is the magnitude, and r head, right? We will use that formula to find out that electric field at the center of this semicircle for each of these charges. So that means the resultant electric field we can find out using that one. It will be the E1 plus E2 plus E3 plus E4 plus E5. That will be my net electric field. Fine. I'll just find out the numerically first. What will be that? E1. I'm not going to plug in the value. I'll plug in the value at the end of this equation or end of this problem. So E1 I can write, which is for this one. I can also draw separately over here so that you can understand properly. Say I'm going to draw, and not necessary. So this is actually the E1, right? E1 is totally towards the positive x direction. Then I can say, I can write K E divided by R square into I hat. This is actually E1, right? It will be towards that positive x direction since it's a electron, is a negative polarity. What about the E2? E2 is going to be created by that proton, which is that one. Now I know this theta 1. If the theta 1 is basically how much? Theta 1 is 30 degree. Then I can say this angle would be also that 30 degree. It means that the E2 has two components. One is towards negative x direction in that, and the y component will be towards the downward direction, which will be also towards the negative y direction. Then I can write this would be K E over R square into minus cos 30 degree into I hat, right, minus sine 30 degree into j hat. I just split that vector. One component will be towards the negative x direction. This angle is 30. It should be cosine 30, and that angle will be that minus sine 30. Right. So this is actually that vector electric field E2 created by the particle 2, which is basically that proton. Fine. Now what about by the particle 3, which is the again the proton? Then I can write this E3, it should be that K E divided by R square. Now look at this. This E3 vector, its the angle would be this total angle. So this is actually the total angle, which is theta 1 plus theta 2. And theta 1 is basically your 30 degree and theta 2 basically that 50 degree. So total angle would be 30 plus 50 is going to be the 80. So that's mean we can say that angle, this one will be also that 80 degree. That's how we will write. And again its x component is negative and y component is also negative. I will write down minus cos of 80 degree I hat minus sine of 80 degree z hat. So this is actually that electric field going to be created by that particle 3, which is basically the proton at the center of this semicircle. Fine. Now what about the particle 4, which is the electron, which will be toward that direction? We can find out that angle also. Say I'll choose to indicate the angle, say the different colors. I'm using that one. So this is will be that total angle, right, which is actually the theta 3 plus theta 4, and its x component is negative. X component will be toward that direction and y component will be towards positive y direction, right? So theta 3 is 30 degree and theta 4 actually that 20 degree. That means this total angle is basically 50 degree, right? Then I can write that vector E4, so electric field produced by the particle 4, which is basically the electron. You can write this with again K E R square is going to be the minus cos of 50 degree I hat, and the y component is positive. It's will be the plus sine 50 degree j hat, right? So this is actually the electric field going to be produced by the fourth particle, which is the electron. Now the last one, the E5, which is going to be produced by that particle 4, which is a proton, with the angle is theta. Then I can say this angle would be also the theta, right? Then its x component is positive and the y component would be the negative. Then I'll write down the E5, then this E5 would be K E R square is going to be that cos of 20 degree, because theta 4 is basically the 20 degree, theta 4 is 20 degree, cos 20 I hat is towards the positive x direction, and the y component will be towards the negative y direction. So it's the sine 20 z hat. So this is actually that electric field going to create by the particle 5 at the center of this circle. Now what will be that net? Net will be sum of these. I'm going to add them together. Now that E net, the center of this semicircle, is going to be that E1 plus E2 plus E3 plus E4 plus E5, right? Fine. Now I'm going to plug in this value and I'm going to separate it I and j component. So then I can write KER square, because I can factor out KER square is present in every of this electric field vector. So that's why I factor out KE. Then I can write is going to be that first is I hat minus cos 30 I hat minus sine 30 j hat minus cos 80 j hat minus sine 80 j hat minus cos 50 I hat plus sine 50 z hat, which is basically that E4, and plus cos 20 I hat minus sine 20 z hat. So this is should be that little vector. Now I'm going to use some calculation over here. So what is that? If you do some calculation, you'll find out that this E net. So if you plug in the value of Coulomb constant and magnitude of this charge of the electron and the radius of this circular track, which is the 2 centimeter, then you will find out it would be 3.6 into 10 to the power minus 6. And if you separated this I and j component, you will find out that it should be 0.257 I hat minus 1.06 j hat. I jump one line over here. So then I can say that this is would be my electric field. So I can say that it should be 9.257 into 10 to the power minus 7 I hat minus 3.816 into 10 to the power minus 6 j hat. So this will be the net electric field at the center of this semicircle due to this 5 particle. Now they ask me to find out the magnitude and the direction. In the question they ask me to find out that magnitude and the direction. So then I can find out the magnitude of vector, right? You know how to find out the magnitude. So the net magnitude would be, you know how to find out the magnitude of a vector. It will be 3.9 into 10 to the power minus 6 Newton per Coulomb, and the angle theta, that should be basically tan inverse AY by X. Using that formula, if you do that, it will find out minus 76.36 degree from positive x-axis or to 83.63 degree. So that should be the answer. You can understand this one, why it is minus 76, because if you draw that vector, your x component is positive, right? So I can draw that using that different colors. Say this is would be the x component toward that direction and y component is negative, so that should be that one. So then the resultant vector will be that one. Now if you use tan inverse AY by X, that would be the angle theta, and it's moving to the clockwise direction, so that's why it's a negative. Or you can say this angle, or you can say that one, which is actually that 283.63 degree. So that should be the answer of this question. Okay, thank you very much.